All right, now we're going to get into adding and subtracting rational equations, solving these rational equations using adding and subtracting. It's good to know some steps. We already talked about the intro, talking about make sure we factor first and then we simplify. After we do that, then we can jump into the actual problem. So what we're going to look at here are first kind of the steps once we get past the simplifying. We got to make sure, number one, that our denominators must be the same when we add or subtract. They must be the same. Number two, if they're not the same, you need to multiply to get like denominators, and you'll kind of see that in the example of what's going on there. And number three, if we're adding subtracting, after we get the denominators to be the same, we're going to combine the numerators and we're going to keep the denominators the same. Again, it's better to see it as I work it out and then kind of reference back to the steps. So let's kind of take a look at some. So we're looking at this first example here. We have 3 over x plus 1 plus 2 over x plus 1. Well, since the denominators are the same, that means that we can add these together because it says adding. We can add these together. That means equals our denominator, like it says here, keep the denominators the same if they already are the same. It's x plus 1. Combine the numerators. Well, 3 plus 2 is 5. That'll be our answer. 5 over x plus 1. All right, that's an easy one. Let's move on to another one, a little more complicated. We're going to write our equals here. Our x, our denominators are the same, which is perfect. So we're going to write out our denominator as x plus 3. Now our numerators are different. We have 5x squared plus 2x. So when we write that out, we just write it as we see it. 5x squared plus 2x. Can we combine those like terms at all at the top? We can. So that would be our answer. Again, first two are fairly easy. Okay, I'm going to start you out easy and I want to work you to a hard one. So now here, if we look at this, we notice that our denominators are the same. So when we write our answer, we're going to write 7x minus 3. Now here, this is subtracting, and we're dealing with a lot more terms on top. So we're going to bring down our terms. Here we have 2x plus 1. And I'm just bringing them down so I can see them all in a line. And then that minus we need to distribute into these this second part up here. So a negative goes in there to be minus 4x, and then a negative times a negative, which gives us the positive 3. All right. Now from there, I've got some like terms kind of going on up here, so I want to make sure I combine those. So I'm going to keep my denominator the same. Nothing changes in the denominator, stays the same. 2x goes with this negative 4x to give us a negative 2x. And then this 1 goes with this 3, so 1 plus 3 gives us a positive 4. That would be our answer for that one. Okay? Now, kind of going over here, this is going to be the grand poobah of questions right here to look at. Going back to what we talked about, denominators. Our denominators, are they the same here? We have an x minus 1 and a 3. Are they the same? No, they're not. So we cannot just subtract these right now. We can't do it. We have to go back here. Denominators must be the same. They're not. So we need to multiply to get like denominators. So how we're going to do that is we're going to look at this. We're just going to multiply this whole fraction by this denominator, which is 3. So we're going to do 3 over 3 times that 2 over x minus 1. The 2x minus 1 came from right here. We're going to multiply by 3. And I just kind of want you to see what's going to happen here. I'll talk about it in another video, but I just kind of want you to see how this kind of works out. So I look at this fraction. I need to multiply it by x minus 1 over x minus 1. So I have 2 over 3 times x minus 1 x minus 1. Again, you can put parentheses around these if you'd like. Sometimes I like to do it just to kind of break things apart. So now we're going to multiply these. 3 times 2 is 6. Make sure I put the equal sign. And 2 is 6. When you do the on the bottom, in the denominator, you do not ever want to distribute. Do not distribute in the denominator. On the numerator, you can distribute, but in the denominator, you do not want to distribute. All right? So that just turns into 3x minus 1. And then I have my minus. All right? I did nothing. I just combined those. 3x minus 1. 3x minus 1. 3 times 2 is 6. Now over here, again, on the numerator, we can distribute. So 2 times x gives me 2x. 2 times negative 1 gives me a negative 2. Over, again, do not distribute on the bottom, which is 3x minus 1. Now, do you kind of see? I'm going to zoom in just so you kind of see what happened here. All right. We went from having unlike denominators to multiplying both sides by the other denominator, and now look at our denominators. They're the exact same. That's perfect. That's what we're looking for. That's what we're trying to do. Trying to get like denominators. Now we can combine the numerators and keep the denominators the same. So here, it's going to come down to 3x minus 1, right? Because they say the same. 6. I have a minus, so I need to distribute that. That's going to turn that into a negative 2x, and that's going to turn that into a positive 2. All right? And from there, we combine our like terms, 6 and 2, which gives us 8. And I still have negative 2x left over. My denominator stays the same, 3x minus 1. And that would be my final answer. Okay, again, not too hard. A lot of this really comes with knowing the steps, knowing the procedure, and again, the more you practice at it, the better you become. So my suggestion to you is maybe go back and watch this video again and practice, or look at the homework, or go to the next video, because I'm going to do 1 through 4 on the next video, and combine our intro with solving rational equations as we add and subtract.